Okay, let's start the geometry class. So previously, we already learned the triangle congruency. And we know that triangle congruency we can use if it's a general triangle, not a specific right triangle. We can prove two triangles to be congruent by S. That's called side, side, side. And then we have side, angle, side. And we have angle, angle, side. And the last one is called the angle, side, angle. In this full method, we can prove two triangles to be congruent. But what will happen if you only know the angle congruent? We already mentioned the 3 theorem last class. If you prove two triangles to be, number one, you have two angles to equal. So here, you have this angle equals this angle. And you have the second angle equals this one. You can prove these two triangles are similar. Do you need to prove the third one to be the same? Not really, because three angle together, three angle summation give you a 180. If you know these two equal, and you know these two equal, then the third one will always equal. So you can use angle to prove two triangles to be similar. Similar means their shape are the same, means their angles are equal, but the side might not be equal. The second theorem is called SSS, as what you see over here. If you have two triangles, you have the three side ratio correspondingly equal, then you can call these two triangles to be similar. That's called side, side, side. The last one is called side, angle, side. When we talk about side, angle, side, we have to make sure you have these two guys ratio equals this two guys ratio. And the angle between this is going to be identical. So that's called side, angle, side. And now we are going to use this 3 theorem to do the triangle similarity. So look at here. If I talk about the two triangles to be similar, see number 2 question. If I say X, Y, Z, if I say this triangle, it's going to be similar to R, Y, S. So this 2 is congruent. This 2 is congruent, and this guy equals to itself. And at the same time, you will write down the corresponding parts ratio. So you will put XZ divided by RS equals to XY divided by RY equals to YZ divided by YS. So you will have this 3 side ratio equal. That's for if you show that these two triangles similar, you will be able to write down all these conclusions. What will happen if it's not a triangle? For example, you have a quadrilateral. You have this one. This one is not a parallelogram. It's not a trapezoid either. It's just any kind of a quadrilateral. If they say J, K, L, M, and then Q, R, S, P. So J is corresponding to Q, and the K is corresponding to R, and L is corresponding to S, and then M is corresponding to P. You have these two guys similar, then you will have these full angles congruent, and then you will have the full sides ratio equal. Okay, yeah. That's based on the two similar polygons. You can give this conclusion, the corresponding angle congruent and the corresponding side ratio equal. So that's a conclusion you can give if you have two similar triangles or two similar polygons. And then we will, based on this, we will do the calculation. Yeah, let's see here. For example, number 5. if you have a scale factor, the guy here is showing you a scale factor. So Haiti, let's try here, please. These two guys, they say a scale factor of 6/5. So that means you can make this guy divided by who equals to 6/5.
Divided by 28.
Okay, so you will make x over 28 equals 6 divided by 5. Okay, yeah, that's what's going on. Okay, so you do this ratio. This guy over this guy is a scale factor, which is 6/5. And then you can do the cross multiplication. So 5x is equals to 28 times 6. Make sense? And then x will be, how much is this? How much is this product? 168, right?
Yes.
So you do 168/5. Okay? If they allow you to use the improper fraction, you can keep as it is. If they don't allow you to do, you will times 2 to the top and the bottom. And then the top one will be 336/10, which is 33.6. Okay?
Okay.
Good. Next one here. Let's call Jeffrey. Let's, based on this two guys are similar, let's write down the ratio, please.
BC and DE are similar.
So you do, when you see here, you say BC should corresponding to EF. Look at here. A is corresponding to D. So you should keep in mind A and D are the same. So this guy's opposite is 28. This guy opposite is 20. Make sense?
Yeah.
So you will have 28/20 equals to this AB. So this is AB. This is going to be DE. Make sense?
Yeah.
Okay. So if you have x over 25, correct? That makes sense? Okay. When you do the ratio, you don't do randomly say, oh, x over 20 equals 28/25. Not really. Based on what you see here, the AB over DE. So AB is x, DE is 25. So this is this. And then the 28 is BC corresponding to EF. So you have to make sure write down this proportion correct. And then we can divide this guy by 4.
It's 7/4.
So divided by 4.
7/5.
Yes. And then you have 5 times 5, which is 25. And then 7 times 5 will be
35.
So you have x equals to 35. Here, when you want to do the simplification, okay? Yeah. In that way, if we simplify the left side, we can easily calculate the answer very quickly, right? Okay, that's pretty good. Next one, Stephen, let's try here. I want you to pay attention to here. So if you do the first two letters, you will divide by the first two letters. If you do the middle two, you will do the middle two. Go ahead. Let's see how we can list the equation, please.
Do I just say like the lines? Like how the lines
Yeah, I think it's better to see here. This is PS, right?
Yeah.
So it's better to write down the letter first and then plug in. I think that's better.
So it's PS divided by WG is equal to RS divided by YT.
So PS, if this is PS, we want to check over here. PS over WZ, right?
Yeah,
equals
equals to R
RS.
divided by YZ.
Yeah, this is RS, this is YZ. Very good. And then
And
we
then
can plug in.
you get 75 over 40 is equal to X over 32.
Okay. And then let's see if we can simplify. Each
You
guy,
you can simplify 75 and 40.
divided by who?
5.
This guy
15
divided
over
by
8.
5.
8.
Very good. And then you can see, oh, this guy times what? So this
4.
guy, yes, this guy times 4. So X will be?
60.
X will be 60. Very good. I never do this way. I never say, oh, I will do 75 times 32. So I will do this guy like that. And then having a big number, then divided by 40. I don't do that way. I always simplify as early as possible. Okay? Yeah, very good job, student. Next one. Any questions so far? We want to talk about the way we can simplify. If you have those kind of basic equations, okay? If you have these things. The guy, both on top, if these two numbers have some common factor, you can do the simplifications by both the top two numbers. If this both numbers are on the bottom, then you can also simplify between here. If they're on the left side, you can simplify here. If it's over here, you can also simplify here. You cannot simplify between these two numbers, because look at this. 7 over 21 is originally 1 over 3. And this is also 1 over 3. If you simplify between here and here, that's going to be wrong. Yeah, this guy divided by 7 is 3. This guy divided by 7, 2. 7 over 3 is no way to equals to this number. Yeah. So if you simplify, you only simplify the top at the same time, or the bottom at the same time, or the left at the same time, or the right at the same time. Okay, that's the correct way for doing the simplifications. Let's see over here. Sophie, let's based on these two guys similar. Let's write down the equation, please.
DE over HJ is
So yeah, I prefer we write down the triangle letters first. The DE over HJ.
is equal to DF over
Good.
HJ
Good.
is equal to EF over JG.
Very good. And then let's plug in.
It'll be 9 over 15 is equal to 12 over X, which is equal to
Oops.
14 over Y.
So DE is 9, HJ is 15. And then DF is 12, and HG is X. And then EF is 14, and the JG is Y. All right, very good. And then we notice that this part we can simplify, right?
Yeah.
How do we simplify this?
You can divide it by 3, which becomes 3 over 5.
So you simplify here by this. Okay, and then you can do this cross multiplication. Yeah.
Yeah.
Let's go ahead. 3x equals
3x equals to 60, x is equal to 20.
So you have 3x equals to 60 and x will be 20. How is the other one? You can do here. Okay.
3y
Yes,
is equal to 70.
good. And then y will be 70 over 3. Okay? Yeah, that's pretty good. We don't need to change this to decimal unless they say, oh, make the close to the nearest tens or hundreds. If they didn't say that, we leave a fraction, totally fine. Okay? Next one. Angela, let's see number 9. Let's see here. These two triangles are similar. Let's go ahead, write down the ratio, please.
A over NN.
So you have
Is equal-
JK, yeah, JK over NM, right?
Yes.
Equals
KL over NL.
KL over ML. And also
JL versus JL over
NL, yeah.
NL.
That's pretty good. And then let's plug in. Who is JK?
JK is 40.
NM,
16.
good. And then KL,
X
and
over
then
14.
good. And then JL,
45 over Y.
yes. Now we want to simplify this part first, okay? 40 over
That's
16 can be cancelled to be who?
5 over 2.
So you divide by 8, so this is 5 over 2. And then you can do the cross multiplication. Let's go ahead.
70 equals 2 of X.
So you can have 2x equals 70, and x will be,
X is 35.
and then you can do the other one here.
5y equals 90.
And
So
y will be,
18.
good. That's pretty good. Next one here. You may say, oh, this part looks so easy. Annie, let's do number 12, please. Based on this small triangle, similar to this large triangle, we will use the ratio equal. Okay, go ahead, please.
Okay. So first we can do BG over BV is equal to BR over BN, which
So
is
you
equal
do,
to
sure, you do the first and the last letter equals to BR over BN, right?
yes, and
And
then
also equals,
RG over NV.
yes,
And then it would be 18 over 8 is equal to 4x plus 7 over 12. And y
here. The RG, we don't know. So you list this guy as Y? Yes.
yes,
Over 10, right?
yes,
Actually, they didn't ask us to solve this, but it's okay. We can list here. So now we can simplify this first. 18 over 8 will be?
it will be 9 over 4.
9 over 4. So did we notice that full triple time, this times 3, so this guy times 3 equals this, right?
Yes.
So that means 9 times 3 equals to 4x plus 7. So 27 equals to 4x plus 7. X will
And
become
x will become 5.
good job. That's it. Okay, that's how we get the x. And then based on this practice, I want you guys, let's try this one here. Number 4. Based on what we did just now, go ahead, try number 4. Solving the x. Go ahead, please. You finish, you can text me or you can send me by email. When you finish, you can text me your work or you can send me to the email where you receive my homework. Okay. Good job. Annie and Timothy got correct answer. Pretty good. Other students, please send me your work either by email or by phone. Good job, Angela. Good job, Sophie. Very good. Other students? Jeffrey and Stephen, you finished? Number 4, okay.
Oh, I was doing number 5.
I didn't show you number 5. How do you see number 5?
Is it okay if I just tell you the answers? Because I don't think my phone's working right now.
Oh, okay. You text me in the Zoom chat window.
I just text you the answer on my work.
So your phone is not working right now, right?
Yeah.
Okay. You just send me in the Zoom by chat. Send me the answer.
And the work?
No, just answer. Are you able to send the work by chat? I don't think so.
Oh, okay.
Okay. All right, you might see this part of the question sounds no hard. So right now, you guys see all those questions are not hard. Now I'm going to give you guys a challenge question. Good job, Steven. That's correct. Now I'm going to let you guys, I will see who can get this one correct. Number 9 is going to be challenge, because this one is going to see if you have your algebra foundation enough. Try number 9, please. You notice that for number 9, you will do the quadratic equations, and then you will using either the factoring format or the vertex or the quadratic formulas to solve your x. This is time to see your algebra foundation. Steven, you calculate very fast. Double check your work. I'm not able to see your work today. You have an iPad, additional iPad, so that you can send me your work, Steve?
I can try my phone again.
Okay. Pretty good, Timothy. Wow, you improved a lot, Timothy. Good job. Yeah, 2 boys already found the number 9. And then you guys can do number 10. If you finish number 9, you can go ahead and run number 10, please.
Wait, I work on number 10?
Yeah, you finish number 9 and then you can do number 10.
Okay.
Chloe, you can unmute yourself. Let's try this one together. We will do this over this, okay? Let's list the letters first.
Okay, AG over FL.
Okay,
And
so
then
we have AG first over FL equals,
GN over LS.
very good. So AG is who?
24 over X.
Good. And then GN is who?
X plus 7 over 6.
Okay. And then when we have this, what do we do? We do cross multiplication, right?
Yes.
Let's go ahead.
Okay. X
X squared plus 7x
plus
equals
7,
to 24 times 6, which is
24
how much?
times 6.
How much? 144, right?
Yep.
And you have x squared plus 7x minus 144 equals 0. Then we do this cross multiplication. 1 by 1 is 1. 144 will be who times who?
144.
See here, 144 is 12 squared.
Yeah.
Yeah. And then
Yeah.
also, this is 12 is 3 times 4. So 3 squared times 4 squared. Did you notice that here? If you have a 9 here, you have 16 here. You can get this immediately, right?
Yeah.
So this means you have x minus 9 and then x plus 16. Correct?
Yeah.
And you cannot make it negative. The segment length won't be a negative number. So you make your x equals to 9. Okay?
Okay.
Yeah, that makes sense, right?
Yes.
Now, number 10. Timothy, yeah, since you do this several questions so fast, I ask you to answer this one, please.
Okay.
Mhm.
So angle at CE or over
And not
what?
angle CE, it's just to see the CE, okay?
Okay, CE
Yeah.
is
CE over
YE.
CE is first and third over YE equals
Equals to SE over JE.
SE over JE. That's pretty good. And then you will
18
have 18, yes,
over X
over
plus 1.
18 over
X plus 1
X plus 1 equals
equals to X minus 2 over 10.
okay.
And then X plus 1 times X minus 2 is X squared minus X minus 2 equals 180.
Good. So you will move this around.
Yeah, 182
Good.
equals 0.
Yes.
And
And
then
then?
it becomes you factor it.
Yes.
So it becomes X plus 13 times X minus 14.
So you think 13 times 14 give you 182?
Yeah.
How did you get this factor quickly?
I tried the stuff around.
So 182 is even, right?
Yeah.
So this 2 times 91, right?
Yeah.
And 91, we know that this guy is divided by 13. Okay? Yeah. So this is 2 times 13 times 7. And then we see this guy here is going to need 1. So 14 and 13 has a difference of 1. So immediately, Timothy is smart enough to figure out, oh, this is the difference between 13 and 14. And that guy will be negative. So you do the cross. Then this guy will be who times who?
X plus 13 times X minus 14.
Good. So x will be?
X equals negative 13 or 14.
But negative 13 won't be correct. So you choose
Yeah.
the positive 14. Yeah.
And then
because- yeah.
angle EY is 15.
That's not angle, that's length.
Yeah.
Segment. Yeah. That's angle. This is length. Okay.
Yeah.
This is number 10. That's pretty good. Timothy, you improve a lot. That's very good. And next one. This is something a little bit different. Just very small change. So for over here, you are not looking for each individual one, but you want to look for the parameters. They tell you the scale factor. So this guy scale to this guy is 3/5. So you can treat this guy as 3. That means if you divide this by 3, that's 4. And then you do 4 times 5, that's 20. So this part will be D20. And the same thing, you divide this guy by 3, which is 2. 2 times 5 is 10. So you have this part is 10. We can do 2 different ways. I want to see students do this question by 2 different ways. First way is you use the scale factor. You find out each corresponding parts. That's called the first method. You find each guy length, and then you plus the 3 together, give you the parameter. The second method is you plus all these 3 together to get the parameter of the smaller one. And then you use the scale factor directly to find out the big one parameter. Try both ways, please. Try both ways and verify if you have the same answer by using these 2 different methods. Okay.
Wait, so we basically do 11?
Yes, do 11. Do 11, but use 2 different methods and check if your 2 different methods are the same. I believe we have students here, 8th grader or 9th grader, very possibly this August. If you are students in Fallback ISD, from the 8th grade, you will take the PICT in October. It is supposed to be the second Saturday of the October. So this basic similarity triangle geometry question will appear in those PICT. Okay, yeah. So if you do well here, that test, you will not worry about question like this.
You want us to submit it?
Sorry, say one more time, please.
Do you want us to send it to you?
Yes, please send me this work. Oh, Annie and Haiti. Very good. You both get the correct answer. That's pretty good. That's very nice. This time, girls do way more faster than the boys. Also, if you finish 11 correct, you can go ahead and round the number 12. They ask you to find the parameter of the TFE. TFE. Go ahead, try this. Very often, the PSCT like to ask the simple similarity geometry questions. It's not hard, but if you never ever try this practice before, you might feel a little bit scared. Okay. If you finish number 11, send me your work. If you send me your work and I say your work is correct, you can do the number 12. Good job, Jeffrey. That's a very beautiful answer for 11. You can do number 12, please. Good job, Sophie. Always, all your work is always neat, very nice, perfect answer. You can try number 12, please.
Can you help me with 11?
Okay, I'm happy that you asked me for help. So you have the scale factors. So we can first write down the ratios, okay? So you can first say KL over who? KL over PQ, right?
Yeah.
Equals
Wait, isn't it KL over Q? Just
K,
Q?
KL over PQ.
Oh, okay. It's equal to
KL over PQ equals
is it
LM.
LM over QR?
Good. Equals
KM over PR.
very good.
It's equal to 3/5.
Yes, thank you. And then we are able to plug in all of them. Okay, so do
Okay.
this first, and then you will plug in. So let's put the guys which we know. Let's go ahead.
15's the first one.
KL is
Wait, 6. And then Q. Wait, yeah.
LM is 15. And then KM
It's
is
12.
12. Yes. So look at here. Let's do some quick way of doing this.
Yeah, I understand now.
Yeah. See here? If this guy times 4 equals 12, so PR should be
20.
So this is going to be 5 times 4, which is 20. And then for the QR,
It's
3
25.
times 5. Yes, good job. And then the next one,
10.
good, very good. And then you plus all of them together will be
55.
good. At the same time, you can also say this, because if two triangles are similar, the individual corresponding side ratio equal, and the parameter ratio also equal. So you can do another way by saying, I'm able to make this equals to KL plus LM plus KM over PQ plus QR plus PR. That makes sense.
Yes.
If two triangles are similar, their parameter ratio is also the ratio equals the same scale factor. So the top one, if you plus these guys together, this becomes to 21 plus 12, which is 33, correct? Yes.
Yeah.
this thing is given. These three guys plus together give you 33. So 3 by 11 is 33. Then 5 by 11 will be
Wait,
5 by
what?
3 times 11 give
Oh,
you a
55.
so you can get this also. Does this make sense?
Yeah.
Okay, that's a way of working on this. Okay.
Okay,
Anybody
so
want to? Yeah, go ahead.
we
What's your
work on
question?
both?
Yeah.
Okay.
If you finish 11, then you can do number 12. Let me check if other students send me the work for number 12. If you finish 11, you can work on number 12, please.
I still don't really get number 11.
Okay, let's see here. We do the same thing at the beginning. You do KL divided by PQ equals to LM over QR equals to KM over PR. Is this step okay?
Yes.
This equals to the scale factor, which is 3 over 5, right?
Yes.
And then the KL is 6, so you plug in. LM is 12, is 15. KM is 12, so you plug in them individually, right?
Yes.
And then this equals this. So you see here, 3 times 4 is 12. 5 times 4 will be 20. 3 times 5 is 15. So 5 times 5 is 25. 3 times 2 is 6. So 5 times 2 is 10. So you get each individual side for this big triangle, right?
Yes.
And then the big triangle 3 area summation is going to be the perimeter. Correct?
Yes.
That makes sense.
Yes.
And at the same time, if two triangles are similar, you can sum all the 3 side ratio. The perimeter ratio is also equal. Okay? Does this method also make sense?
Yes.
If two triangles, let me say this one more time. If two triangles are similar, the side ratios correspondingly equal. The perimeter ratios is also equals to the same scale factor. Okay? Yeah. And then you have this. And you might feel curious. What's the reason you can write down this? Why you can add them? How do you know this is true? So if you are curious, it's good. If you are thinking this question, then you are trying to understand the true story. So here is real reasons. So let's do this. If you do A1 over A2, I'm going to redo this. This is something important. You see the geometry and algebra are connected. Yeah. So I'm going to change this guy here. If you have A1, B1, C1, and D1, and you have this, if you have this equal, if you have all of this equal, then you will be able to say this guy equals to all of this together. No matter how many terms you have. If you have 100 columns equal, you can add in all the 100 top and 100 bottom. It's going to be, ratio is going to be equal. Okay, yeah. Can anybody try? Everybody? We can prove if this is true. So the statement is if this is true, then this is also true. You can try to prove this one. Why, if the first one is true, and the second one will be true? That's quite interesting. Jeffrey, let's see here. What's the reason that we can see this to be true? We can make this guy equals to a k. Okay? Yes. We can say this
Right.
equals to a constant ratio, right?
Yeah.
So tell me A1. A1 is k times A2, correct?
Huh?
And then same thing. Oops. I want to copy this. So if your A1 is equals to this, so your B1, C1 is always has the same pattern. Your A1 is k times A2. Your B1 is k times B2. Your C1 is k times C2. And your D1 is k times D2. Okay? Correct? Yeah? You agree with
Yes.
this? Yeah. Okay. Now, this is going to equals to,
4k.
yes, exactly. Because you can look at the top.
Because each one equals k.
Yes, exactly.
It's just added together first.
Yes. So you have k A2 plus k B2 plus k C2 plus k D2 over A2 plus B2 plus C2 plus D2, which is equals to k. Okay?
Okay.
That makes sense?
Yes.
Yes. So this is the background to support our red method. This is the background to support this to be true. Okay? Makes sense?
Yes.
If two triangles, actually, this is very interesting. If two triangles are similar, if you draw the height like this height ratio also equals to the same ratio. And the parameter ratio equals the same ratio. But, Jeffrey, I asked you a
Yes.
question. If I see these two guys' area, how much will be this guy and this guy area ratio?
3, 5.
The parameter is the 1D. The area is 2D. The area is going to be the base times the height. Just now I said, oh, you see here? This guy over this guy is 3 over 5, right?
Mhm.
And that guy over that guy is also 3 over 5. Your triangle area is your base times height divided by 2. Everybody is divided by the same constant 2, so that thing will cancel. So the base times height is going to be this guy over this guy is 3 over 5. This guy over this guy is 3 over 5. So your area is going to be 3 over 5 parentheses square, which is 9 over 25. Does that make sense? That makes sense?
Yeah.
This is what's going on. Write down this conclusion. This is critically important. Very possibly you will see this kind of question in the PSAT. Okay, if you see this question and you do correct, please let me know. Look at that. Does that guy make sense now to everyone? Next. Look, here we will see those scale factors, not only just the triangles, but also the rectangles. So the guy here, when you do the scale factor, you want to pay attention to the way we call the scale factor. If I say scale factor from A to B, then you will do the B over A. If you do the scale factor A to B, then you will do the B dimension over the A dimension. So here, this guy over this guy to this guy is you do this guy's dimension over that guy dimension. You do the long side ratio, 16 over 4, which is 4, 8 over 2, which is 4. So the scale factor is 4. Okay? Yeah. And you notice that, Jeffrey, you see this guy area over that guy area is going to be not 4, but 4 square. Because 8 divided by 2 is 4. 16 divided by 4 is 4, so it's 4 square. Does that make sense? Yes, Jeffrey. That's pretty cool, right? And then let's see number. Let me see if we have some more difficult questions. Yes, I'm going to give you guys more challenge questions. All right, let's try here. Try 13, please. Do the proportion. This small triangle is similar to this big triangle. So you will have this side over that whole thing equals to this side over this longer one. You don't need to worry about here because they didn't mention any letters or numbers. So you don't need to worry about this side. By doing here over this whole thing equals this guy over this whole thing. But don't say 8 over x plus 5. That's wrong. I didn't say this guy over this part. No, I say this guy over this whole thing. So you need to pay attention. Write down your correct proportion equation, please. Go ahead, try your number 13. But if you say, I have trouble for this one, I want you to walk through with me, you can unmute yourself. I will go through number 13 with you together, okay? Anybody, if you need help, just unmute yourself. Let me go through this with you.
Can I do it with you?
See, we still do here, okay?
Okay.
This is PQ, so here is PQ. So we do PQ, SQ. Now we do the letters first.
Okay.
So PQ over
SQ.
equals
PR
good.
over ST.
T. Good. You because you see here, first 2 letters, and then first and 3. Yeah. And let's plug in. PQ is who?
PQ is x plus 13.
Good. over
over 8
PR.
21
Good. Over
over x minus 9.
good. And then let's do the cross multiplication, please.
Okay. X do the okay.
Do the
X
cross multiplication.
squared.
Yes.
Yeah, x squared minus 117.
Hey, hold on. X squared. You do the following. X squared minus
yeah.
9x.
X squared minus 9x plus 13x
And then,
minus 117.
so this is 117. Yeah.
Mhm.
And then equals.
Equals 168.
And we can move around. This is plus 4x. And then minus what?
Minus 285.
Okay, yeah. If you need to use bathroom, quickly go. And then when we see this number, this is a little bit big, but we can simplify. Yeah.
Yeah.
So 285 is divisible by who? That's the thing we know first.
5.
Yes. So it divided by 5. This is 5 times who? 5 times
57.
57. This two number is not going to give us a 4. And 57 is who? 57 is divisible by 3, right?
Yes.
Okay. So it's 3 times
19.
good. Did you see the pattern now? You want to get two numbers, which these two numbers will have a difference of 4, so that you will meet the 4 here, right?
Yes.
Did you see 15 and 19 is going to meet? So 1 times 1, and then who times who?
15 times 19.
Who is positive? 19 is positive.
Yeah.
So you have x minus 15 times x plus 19 equals to 0. So you have your x equals 15, right?
Yes.
Okay. All right. That's pretty good. Oh, this is question 13. Good job. Next one, number 14. Anybody want to try 14 with me? Anybody? You do with me together? Jeffrey, let's do it. Let's go ahead. List the equation, please.
So CD equals GD.
Mm.
CD over GD
Good.
and DE over DF.
CD over GD equals to DE over DF. Okay.
So it's 15 over x plus 3 equals 3x plus 1 over 4.
Mm-hmm.
Then
Very
cross
good.
multiply, so it's
Yes,
60
very good.
equals 3x squared plus 4x plus 3
So we have,
plus
hold
10x
on,
plus 3.
3x squared plus 9x. And then plus 1x
plus 3.
plus 3. Very good. So 0 equals to
3x squared plus 10x minus 57.
good. And then we will do the cross multiplication for this one, please. 3 is 1, 3. And then so 57 will be who? 57 is divisible by 3, right?
Yes.
3 times what?
19.
3 times 19. And then did we see the correct?
9 and negative.
Yes.
So -3 and positive 19.
That's right.
So x equals 3.
Good. So 0 equals to x minus 3 times 3x plus 19. So you have x equals to 3. All right? Yeah. You want to try negative? Nope. Because you have 3x equals 19. Then this is negative 19 plus 1. That's going to make this negative. We can not choose this. We only choose this. Okay? That's pretty good. Yay, that's 13 and 14. And then they ask us to check if the two triangles are similar. We have 3 classes for the triangle similarity. This is the first class. We don't have the proof involved. We based on the calculation only. But next class, which is this Sunday afternoon, we will have this intensive proof questions involved, which we will deal with those kind of long paragraph proof. Okay, yeah. So make sure let's master everything we have learned today, and then on Sunday class we are ready for doing the proof questions. So for this couple of next several example, it's not asking do the ratio, they are asking using the angle to check. So here, these two triangles, they ask you if they are similar based on angle. If yes, then you have to write down which statement support these two guys to be similar. Okay, yeah, so you can see here, number 1. And let's see here. Does these two guys, if you draw the lines like that, and then you put this is saying these two guys are similar. The line here is parallel. So you see this parallel. And if you see this parallel, yeah, you have what can angle equal? Go ahead, please.
You know, the vertical angle would be equal.
So you draw this guy equal because vertical angle. What else?
And we also know alternate interior angle.
Also, we know the alternate interior angle, like this. Yeah.
Yes.
So so that makes us give the conclusion saying these two are similar, right?
Yes.
Okay, so we will say, oh, because of AA, we can say triangle. Go ahead.
Triangle BGE is congruent to triangle
We don't say
G.
congruent. We say similar.
Is similar to triangle GFE.
Good. Very good. And you can do next one also. Number 2, please.
So we know that they share the top angle.
Yes. Reflexive property. And then?
Yes. And then we also know that we know corresponding angle.
Good. And then we will see triangle.
That triangle LPQ is similar to triangle LNM.
Excellent. Good job. Very good. This is also because of AA, right?
Yes.
Good. And then let's see over here. Timothy, you're doing very well today. Let me see how you do number 4, please. Look at this. Do you think these two triangles are similar? Yes or no?
Yes, no.
Let's see here. We don't quickly say yes, no. We want to check how much is this angle. Can you go ahead?
58.
So you find out this angle here to be 58. So because this is 1, 1, 2, and then plus that, yes. How much is here?
49.
49. It's because this plus this is 131. Yeah, good. So you have just one angle congruent. Then these two are not, right?
Yeah.
Right, so not similar. If you have just one angle same, but the other two are not the same, then it's going to be not similar. Okay,
Okay.
very good. And I want you to do one more here. This time here, the question is going to be a little bit tricky. So you have this angle between equal, and then you want to check the ratio. Go ahead, please.
Wait, me?
Yes.
Okay.
Uh-huh.
20 over 8.
So you do, no, don't do 20 over 8. It's 20 over 28.
Oh, 20 over 28, yeah. You can simplify that
Yes.
to 5 over 7. Wait, yeah, hold on.
So you do 20 over 28.
Yeah.
And then you want to check if this equals to 15 over what?
15 over 21.
Good. And you also have the angle between, yeah?
Yeah.
You also have the angle between. So let's check. This guy simplified to be
4 over 7. I mean, no, 5 over 7.
and this guy simplified to be
5 over 7.
that equal, yeah? And they have the angle here equal. You see, do I need to check this? If these two guys have the same angle between, if you check this over here, you can support this similar already. You don't need to compare. But if you are curious, you check. It doesn't hurt. This guy divided by 5 is, divided by 6 is 5, divided by 6 is 7. Yeah,
Yeah.
makes sense. Yeah. And then, let's see here. I'm going to delete this work. This one needs some foundations for number sense. Go ahead, do the ratio. When you do this, no, you do on your own paper.
Oh,
Do
okay.
this, check this, and see if this is supported by SSS. Okay? Yep.
We do 8, right?
No, you do 7. I just read
Oh,
down
okay,
my
my
work
bad.
rule. I gave you the tricky number to see your guys' number sense foundation. when you do the triangle similarity, you want to make sure you do the large side over the larger side, the smaller side over the smaller side, okay? When you do the ratio, if you do the wrong part, for example, if you use this guy, divide by that guy, that's going to be wrong. You use the longest side over the longest side, equals the shortest side over the shortest side, equals the middle one over the middle one. But if you match them to the wrong position, there's no way you can find out the correct answer. The number is a little bit big. I don't really want you guys to use the long division to get the decimal values. I want you to observe the numbers. There's something, if you apply that small trick, you will be able to say, oh, if I do that way, it's going to be way more faster. What does that mean? Say, if you want to use that guy, divide by that guy. So if you want to do this way, too slow, don't do this way. And you do this 14 over 13.5. You feel crazy. That's not the correct way of doing this. Let's see here. The trick is this. You use the longest side over the longest side, you see here. So, Jeffrey, let's see here. You have 20.25 over 31.5. 31.5.
Yes.
You want to check if this is equals to 9 over 14. And you also want to check if this is the 13.5 over this 21, right? Yes.
Yeah.
Longest over longest, and the shortest over shortest, and the smallest over smallest. So we have these three listed, correct?
Yes.
After that, we want to check. This is integer, yeah. This is
Yes.
integer. So 13.5 over 21. If I times by 2, did you notice that? This guy double is 27. This guy double is 42. And this is divided by 3. This is divided by 3. So it's a 9 over 14. Correct?
Yes.
And then same thing for this side. Even though this is an ugly number, but I know that 4 quarter is $1. So I will double and double again. When I double this is 40.5. When I double this is 63. When I double this again, this is 81. When I double this is 126. Now you have 81 over 126. That's divided by 9. 1 plus 2 plus 6 is divided by 9. So this is divided by 9. After you divide by 9, this is 14. Do you see a beautiful 9/14 for each term?
Yes.
So it's yes. If any student, you do this question by this, I suggest you not doing that because this is not divisible, okay? This is not divisible and you have some really ugly number. I believe the amount of time you do this division will be longer than everything I do this together. And if you do that division and you do that division, your brain hurts, okay? I don't like those slow method. I do some observation. If my last digit is 5, after I times 2, I'm able to get rid of the dot 5. If the last 2 digits are 25, I'm able to get rid of that dot 25 by times 4. So that's why I use this method. Okay? Everybody understand this number 7 now? Does this make sense to everyone? List your equation or proportion correctly is the first step. If you move this to over here, and that over this, and that over this, no matter how much amount of work you do, you won't be able to get the correct answer. So number 1 step, the smallest, the middle one, and then the longest. Now do this thing first, list them correct, and then do the observation. This is dot 5, I double. This is dot 25, I times 4. In that way, I'm able to solve, all right? Number 7. If I now show you guys my notes, can you repeat this work by yourself? I do want to train students to use number sense to do things very smart. If in the real SAT or PSAT question, or in your school quiz or test, if you can do some number sense, you will save a lot of time and you will finish the work. You have time to double check. Okay, any questions so far? Now look at this. This thing is the major thing for our next 2 classes. Our next 2 classes will focus on doing the proof using either angle similarity or side similarity or side angle similarity. These 3 are the major things for the next 2 classes. Yeah, and also the triangle similarity proof is going to be way more complicated than triangle congruency proof. So let's make sure you truly understand these 3 theorems. Okay? Go ahead, draw this thing on your own paper. I don't want you to say, oh, you already have the PDF. Well, I just opened my phone, I have it. No, that doesn't belong to you. Unless you draw this thing by yourself, the muscle memory is going to help you remember and understand this. So go ahead, draw this. Today, before you leave, you need to send me a picture of this work. I need to see. Draw this thing. Draw 3 columns. First column is called AA. Second column is called SSS. Last column is called SAS. And then you want to draw examples. You don't need to draw 2 examples. If you draw me 1 example, it's good enough. First example showing you have these 2 triangles, which 2 given angle corresponding equal. The next one, SSS, you show a beautiful 2 triangles which their 3 side ratio equal. And the last one, you will mark the angle here congruent, and then you mark the 2 side ratio equal. Okay, show me a graph like this. Okay, Annie, thank you for your notes for this 3 important theorem. Other people have finished this? Send me pictures, please.
Can you zoom in a little bit?
Okay. So you guys know that for the whole high school, if you are going to learn AP pre-calculus and AP calculus in high school, so including Algebra 1, Geometry, Algebra 2, pre-calculus and calculus, all these math courses, if you put all those formulas together with the concept definitions, theorems, conclusions, postulate all together, it's going to be thousands of them. Yeah. So you don't expect you to learn everything at your last year of high school. You want to build up this foundation very well. You have your algebra and foundation already finished. And then you build up your geometry foundation very well. And then on top of these 2 courses, you will have the next layer is going to be Algebra 2. After your Algebra 2 foundation pretty well, you will be ready for the pre-calculus. After all this ready, then you can build the next level, which is calculus. Okay. If you leave today's burden to your next year, then your next year is impossible. So we want to build up foundation pretty well here. This is critical 3 important theorem. Write down. Send me your work quickly, please. Good. Timothy, you are doing very well today. Thank you so much. I will make sure I let your parents know about your big progress. Very proud of you. Good job, Angela. Thank you for sending me your notes. Other students, please send me your notes. The homework I uploaded is already here. So it's called this one here. For these notes, I know that this is many pages. So if it's too much and already your school start, so you have the freedom to choose doing just the odd or just the even and send to me. Okay. Yeah. Because your school already start and this part of the calculation question is not so that hard. So if you choose doing just the odd or just the even, that's fine. But the next class on Sunday afternoon, for the proof question, we will not skip. We will do every single question for the proof. Okay. Send me your work. And then if I check, I say yes, then you can leave now. Haiti, thank you for sending me the notes, but please also draw some figures. The one picture is equals to 1,000 words. Okay, so you want to mark some pictures there to help you truly understand. Oh, I didn't check my email. Let me check my email. Good job, Jeffrey. Jeffrey, you want to put some angle. Okay, I see what you did. Thank you, Jeffrey. Sophie, always very perfect. Thank you. Stephen. Okay, yeah, Stephen, that notes is pretty good. Very good. That's pretty good. Yeah. If you send all the work of your notes, then you can leave. That's for today's class. Okay. All right. See you on Sunday afternoon at 1:50. Okay, we have class at 1:50. Thank you. Katie, yeah, send me your work, then you can leave. Okay, you include some graph. Angela, you send me your work already? Yes.
I have one more.
Okay.
I only sent 2 of them.
Okay. Yeah, pretty good. Yes, good job, Chloe. Yeah, I like the notes you mark over there. That's going to be a good preparation for the next 2 classes to do the proof question. Thank you, Chloe. Thank you, Haiti. Thank you.